Okay, welcome to today's talk in the geometry seminar of the University of Granada. I have the pleasure to introduce Professor Marie-Amélie from Imperial College London. She kindly accepted the invitation to our seminar to talk about the use of generative artificial intelligence in formal proofs. She is not in the team developing these tools, but she has some experience with how to use them in real teaching. So please, Marie-Amélie.
Okay, well, thank you very much for inviting me to talk about this tool we developed in the last 2 years at Imperial College. I'm not very used to talk in seminars about things other than math, so bear with me and stop me if you have any questions. So the idea we had is because one of the problems we have with our students is that they always ask for more feedback. So we have a cohort of about 300 students in mathematics starting every year. And we have problem sessions, which are like an hour per week. But it's the entire cohort being shared in 2 or 3 rooms with a teaching assistant trying to help them with the problem sheets. We have relatively few assessments. So they have a final at the end of the year, and they have maybe 1 midterm and 1 coursework. So in general, there is very little feedback we give to the students. And so one of the general criticism we always get is we want more feedback, and we want more targeted feedback. So the idea I had with a collaborator of mine who is an LLM expert as well is to try to create some feedback tool using AI, which would be able to look at the student solutions to problems from their problem sheets and give them appropriate feedback, following, of course, our criteria. So Aaron Gore is my collaborator, who is also an LLM expert, and Kevin, Stephen, and Inigo were the 3 students who helped us develop the tool during a summer project, which we started last year. So I'm going to talk about that now, and again, feel free to ask me any questions if you have some questions. So what is the problem? So one of the problem in mathematics, as you will know, if you're a mathematician, I don't exactly know what the audience is here, but the main problem is that the new students, the freshers, usually struggle to write mathematical proof, which are not based on intuition, use formal mathematical language, and are rigorous. So this is something which they really have to learn in their first year, and it's also completely new when they come from high school because they haven't been exposed to these type of proofs. So the second problem is that human feedback, so our teaching assistant as a lecturer, the feedback is often delayed because we get the solutions of the students and we have 2 weeks to correct them. The courses go on, right? So 2 weeks later, it's not anymore the topic they have been writing their proofs on. And very often it's vague because we don't have the time. So we just write one line, it's wrong, but there is no appropriate and targeted feedback to the students. A problem we have here, especially at Imperial College, because we have such large cohort, but I believe in a lot of universities it's the case, is our teaching assistants are overworked. So usually they are PhD students who have also to work on their PhD, have lots of marking to do, and then grading proofs is slow, and having a sustained attention when you do that for 300 students is kind of hard. So our idea was, could LLM help with that, with a timely and high quality feedback? So the goal of our work was to look at, so we looked at various LLM large language models, but the one we particularly used was ChatGPT, Omnian 4, and to evaluate how we can give formative feedback on these mathematical proofs, especially at the undergraduate level. So what the tool had to focus on was to respect mathematical rigor. So why does rigor matter? So for the one who are used to doing mathematical proof, it's kind of clear. rigor is the difference between intuition and reliable knowledge, right? So I mean, like, you cannot just draw a picture to prove something. You really have to follow these mathematical steps in order to build a proper proof. And especially in the first year, students should learn how to use formal definition and axioms in order to write this proof and to justify each step with this definition and axioms. So the proof must be not only correct, right, but it must be also readable. You must be able to follow each step. And if possible, it has to be elegant. So then some proofs could be like correct, but extremely long and convoluted. And that's not what you want to have. So elegance and conciseness is also something which we want to teach to our students at undergrad level. So feedback should flag logical gaps. That was the very first thing. Like, the proof should be correct. Vague language, because we want to use this formal definition and axioms. And the proof shouldn't be overcomplicated, of course. We want to have something elegant and nice. So this is why, this is what our LLM, our tool, should be trained on when we develop it. So of course, before using a large language model for feedback, you have to think about what the advantages are and what are the potential risks of using LLM for feedback. So the strengths are quite obvious. You feed the solution to the LLM, you get an immediate response, right? As opposed to you students hand in solutions and then markers have 2 weeks to mark it, and then, you know, like, so it's a quick response is what we want here. It's scalable. So I mean, like, you could have some analysis problems, some linear algebra problem. You could have problems from year 1, 2, 3 for the LLM. As long as it's able to solve the math behind it, it doesn't matter. And also, it has a very broad knowledge. So even if we have PhD students or even lecturer, you know, who are specialized maybe in analysis, and they won't have the knowledge to correct some maybe more advanced topological problems or whatever. So I mean, like, these LLMs has all this knowledge at the same time. Of course, the risks, we're well aware of the risk. If you have used LLMs and ChatGPT before, you know that it's potentially hallucinating. So for example, if you ask an LLM for references in a topic, and if it doesn't know any references, then it might just create some. And then you have to be well aware of this hallucination and be able to train it. Maybe not to completely cancel it, because that's hard, but at least to have as little hallucination as possible. Also, if it doesn't know the answer, which can happen, then it won't say that it doesn't know, but it would just give you some overwhelming and vague feedback. So that's one of the tendencies of the LLM, which you might have noticed as well, is that it will never say that it doesn't know. It would just create something. And inconsistency, of course, therefore, is a risk of that. The other problem which we thought about, especially if you use LLMs in education, is that it needs safeguards, right? So I mean, like, that the students are not allowed to feed anything to the LLM, because then you could have like some potential risks to the users. But we found several ways in order to diminish the risks. So one of them was to just prompt the feedback. And what I mean with that is that you just give it some orders, some tasks to do, and to break it into smaller steps, right? So I mean, like, I will talk about that later. And curated prompt can help as well. So what is a curated prompt? It's just a ready-made script you give to the AI before start. So you tell the AI who to be. So you give it a persona. For example, you are a teaching assistant at a prestigious university or whatever. How to talk. So be professional, but nevertheless understandable to a first-year student, for example. What steps to follow. So answers have to be consistent, safe, on task, etc. And why it helps is that then you get fewer mistakes and hallucination, because the LLM knows exactly what to do and exactly which steps to follow. And it also helps because then you get the same quality for every student because you have given the LLM the criteria to write the feedback. And the last advantage given by curated prompt is that you can build in safety rules and tone, right? So definitely these curated prompts, I think, are the way to go if you wish to build such a tool. So the motivation behind all of this, I've talked about this a little bit, is why the feedback on proofs is so hard for human markers, but also for LLMs because of that. I mean, LLMs are created by humans. So one of the difficulties is proofs can be mathematically sound, but very badly written. So how do you correct it? Attempted proofs may be incorrect, right? So like the proof is not right, but the idea is correct. The intuition behind it is correct. And then of course you cannot give 0, right? You deserve some marks. On the other hand, a proof may be completely correct, but it doesn't use the tools that the students are allowed to use. So this is especially something which we see in our first year lecture. Some students have already learned the material or they think they know the material. So they don't go from the axioms, they just do a small proof. I think they think they're done. So the proof is in principle correct, and that would be correct for higher years, but not for an undergrad, where we precisely want them to use particular tools. So as I said, elegance is important. So a correct proof can be, we can have a proof which is completely correct, but then there are lots of additional unnecessary steps in there which we want to avoid because, I mean, like as a mathematician, we want to be able to, at the same time, be correct and concise. And on the other hand, I mean, if you have a gap in a proof, does it make the proof incorrect? And as I said before, I talked a little bit about it before, it completely depends on the context. So in the context of a year 1 class, well, a gap might be indeed incorrect because you want them to have all steps of a proof there. But in higher years, you might want to say, okay, you don't need to start from the axioms. You know, a 3rd year or 4th year student should know about that. And then a gap is entirely fine because everyone knows that they know. And the very last thing is about mathematical writing and communicating your work properly. So this is more about, you know, how to write properly, simply. So on one hand, you have like this result, which might be correct or not, but on the other hand, you want to be able to communicate an idea to others in a nice and simple way. So it's not only a mathematical problem, but it's also a language problem, an English problem in my particular context. So how can we hope, the challenge is, how can we hope to give good feedback on all of these automatically? So what we want to do is to look at the challenge, to see the potential of the LLMs for each of these particular challenges. And then I will explain what our approach is. So the first challenge we have is we want timely feedback. So we don't want the thing to take ages to give an answer, to give a feedback. And LLMs are perfect for that because if within some seconds or minutes, if the problem is a bit longer, then you get a feedback generation. But it can still be long, and it can still be too long for the students who don't want to wait 5 minutes if they enter the solution to get the tool to give them the feedback. So our approach was to pre-compute certain parts of the task. So again, curated prompt are the way to go here. The second challenge is consistency. So we want the feedback to be the same for all the students who take the course. And as we know, LLMs are not deterministic, right? So it could be that they find some mistake by some students and give some completely other feedback to others. So the potential of the LLMs here that it's trained to follow instructions. And so again, optimized prompts is a way to go here, and also low temperature inference. So that what you can do is that you can tell the LLM that it has temperature is 0, which means that it should be as deterministic as possible. So for us, it's better if the temperature is low. The next challenge is clarity. And well, the potential of LLMs is that it has this huge knowledge, these huge data sets of questions, which it knows already. And again, our approach here is to like tune this knowledge to the level of our students. So again, this will be done by prompting. And finally, the pedagogical helpfulness. So the advantage of the LLM is that it's infinitely patient. So I mean, like there are some studies actually in education where you look at the feedback given the feedback given by markers depending on the time of the day, and it was showed that that the later in the day the marker is marking, the worse the feedback is getting, and also after like 300 copies, 300 exams, you're probably not giving the best feedback either. So the advantage of the LLMs here is that it's, you know, it doesn't feel the time passing and it doesn't get tired. And to be at the appropriate level of helpfulness, you can give it suitable personas. So this is actually a funny thing. So we have tried with several personas for the feedback. And the first one we try is that you are a teaching assistant at prestigious universities. So these work fairly well. And then we took lecturer, professor, and at some point we took Terence Tao, which is a well-known field medal. And then it kind of completely break down. So he was getting very arrogant and not giving helpful feedback anymore. So it was funny to see how the suitable persona actually changes how the LLM react to it. But I'm going to talk a bit more about this later. So what are the principles of designing this system? So accuracy, we've talked about it. Feedback should reflect mathematical and pedagogical correctness. It should have a certain reconfigurability. So we have several courses in different years. And so the workflows and our prompt should be adjustable to the level of the student and also to the content of the course. We should design it in such a way that it's safe. So we should filter harmful content and make sure that the feedback is helpful and not harmful, right? I mean, we don't want the feedback tool to tell our already stressed students, oh, this was completely idiotic what you did, you know, you're not worth taking a math course. I can give a very extreme example, but sometimes LLMs can be more harmful than helpful in such instances. And the last principle we wanted is to have a good maintenance. So in case of retirement of a model, for example, we should still be able to use this system and still be able to tune it. So this was basically the 4 principles we tried to follow. So I talked about prompting before, about this curating prompt, which was basically a ready-made script to you give to your LLM before start. And in order to do that, we use a multi-stage pipeline. So what is that? It's just a workflow, so a list of order splits into ordered steps, where each step takes the previous steps outputs as input, right? So this means that complex tasks become a sequence of simpler and reliable transforms, right? So this is basically what this prompting of multi-stage pipeline is. And in principle, this works with many different underlying language models. So we have tried it with ChatGPT, but we've also tried it with Claude. And at some point, we also tried it with local models. But this was not as effective because I think the way, I mean, like local models have some limits in mathematical solving. So that was not, but I think it will get better. And potentially you could just use local models to do that, which would reduce the cost as well, because costs are a problem, of course. And the good thing is that you can also use different models for different steps. So for example, if you tell the model, read the solution of the student, well, this is something which might be not as hard for a model. So you could take something which is less, has less performance, but which is less costly as well. But then when it comes to the feedback, to interpreting the student solution, then you would take maybe something like ChatGPT, which is has a better performance in understanding mathematics. So having these multiple tasks, so separating in multiple tasks gives you a lot of freedom, actually, and makes the tool modular. And the advantage is also that sometimes you can pre-compute parts of the task. So for example, you can give it fixed, you can give it pre-computed solution to questions, you can give it a mark scheme, you can give it rubrics, and so on. So this is another advantage of this prompting structure. So I just want to give you an example of what I explained before. These multi-stage, fictional multi-stage pipeline. It's not the one we use, but it's an example of what you could do. So the first, say, part of this prompt would be write an exemplary solution to the extracted question. So what it does is that it sees the question and it looks at the solution, right? Then the second set would rewrite for clarity and conciseness. So it looks at the solution and it rewrites it in such a way that it is clear and concise. Then it takes its input and it evaluates the student's work against the solution it has created. And then the last step is to give feedback. So it will write the feedback, compare it to the criteria it has, and then gives the feedback based on the course context. This is an example of a prompt you could give to your LLM. But there are many ways, and of course, every time you write a prompt, you need to train the LLM, and you need to test it, right? You need to go through a lot of tests to see if the feedback is worthwhile, if it works. So let me talk maybe a bit more about the context, how we started it and what we used it for. So the context we first used. So now it's we generalize it actually. All our first year lectures in pure mathematics are using our tool this year, and it's working better than last year, and I will explain why. So, but the original context of the tool was Introduction to University Mathematics at Imperial College. So this is a very intense 4-week course, which is taken by all the first-year mathematics students when they arrive. So they're coming from high school, and that's the very first course they take, and it's the only one as well during 4 weeks. So they have, I've been part of this course. I was one of the lecturers. Usually there are 3 lecturers. And we work as a team, really. So everyone is always there. They have like 20 hours of contact with us per week, with lots of problem sessions, teaching assistants who are helping them. But again, it's a 300 students cohort, right? So giving them proper feedback is hard. And it's a very challenging course because it has branching purposes. So it's designed really to transition the students who come from high school, who have the only experience they had with math is really the school level math, to a university level rigor, to proofs, right? To write proper mathematics as we used to. So the focus of this course, it's still very low level in a way mathematics, but very, very fundamental. So it starts with logic, sets. Then we have function, relations, then number systems. So we start from the natural number and we go all the way to constructing the reals. Then we have technique of proofs like induction, and then a bit of linear algebra, vector geometry, and more applied math. But the emphasis really is on how to write a proof correctly. So it's proof writing. So we started with during these months, they have lots of problem sheets. And they have like maybe 100 problems or something like that they need to work on but they don't hand them in. So they work on it, but as I said, they don't have proper feedback. So the data set we had, we trained our LLM on, was 65 student submissions taken from the IUM. And I will tell you in a moment how we did it. So why is this course particularly important? Well, because it provides diverse and structured proof attempts. So it's a perfect course in a way to test feedback, to test such a tool on, right? Because it's ideal to test the effectiveness of the automated feedback on this thing. So it's at the same time, it's very fundamental mathematics. The emphasis is on rigor and very precise steps within the proof. So this course was kind of ideal to start with and to test our LLM. So what was the data set from the IUM we used to test our tool for? So we had, this was a program we started last summer. And so we had, so not this summer, but the one before. So we were, I was the lead of these projects, and my collaborator, who is an LLM expert, was taking care of the prompting and the programming of the tool. And then we had 3 students who had just completed their first year and their second year. So we had a mix of students. And those were the 3 team members composed by students. So what we asked them to do is to take these 65 questions from the IUM and write student-style solutions to them. And we asked them explicitly not to write perfect solutions, right? So we asked them explicitly to make deliberate mistakes, to reflect common misconceptions. And the 2 topics we chose were proof-heavy topics, so number systems, so really trying to build proof from axioms, inequalities, like this type of equivalence relation, and something which was more applied, so that we had kind of diversity, which was more vector geometry. So really, we wanted to test 2 relatively different topics in math, but nevertheless with some very detailed proofs. So then these students wrote the solution to each of the questions, and each solution was graded independently by 3 human graders. So one of the grader, I was one of the grader. I took my PhD student at the time to be the second grader because he had helped with the IUM. He has been a senior GTA for the IUM, so he knew the topic and the material very well. And then my collaborator was a third human grader. So he has a PhD in math, and he knew the topic as well, but he had not been part of this course. He hadn't taught this course. And then human feedback. So we marked the answer of the students, and each of us wrote feedback for all of the questions for each submission, so that we had a realistic formative comment from human markers. So what was the goal here? So the goal was to build a representative data set for evaluating the accuracy and helpfulness of the LLM-generated feedback. So what we wanted is to compare these feedback from humans to the LLM feedbacks we were getting from the tool. So as I said, each solution was graded by 3 human markers, paired by human written feedback, and then it was processed by a LLM based on some workflows. So we had several different workflows, several different prompts we tested to generate the automated feedback. And then those solutions were graded by the LLM in a final step using grading criteria which we used to mark, so very close to the human grading skill, but in more detail. So we give to the LLM more detail criteria to be able to mark. So the goal was to measure how well the feedback was in comparison to the human feedback. And we use correlation between LLM grades and human grades as a primary tool to evaluate the feedback quality. But what we also did is that we looked at each of the LLM feedback we got, and we evaluated it. So this was quite a lot of reading and quite a lot of work to see if indeed for each of the questions, the LLM was giving proper feedback. And then we optimized the prompt. So what we did is that we, as I said before, breaking the prompt in discrete stages is very, very important, right? So what we have is that we ask the LLM to extract the question, generate the solution, synthesize the feedback, and then looking at the feedback and reading the feedback, we try to improve these different steps and improve consistency of the feedback. So this was something really which we did for 4 or 5 weeks, trying to optimize these prompts and to change these prompts in such a way that it was exactly giving the feedback we wanted. So it's quite a lot of training. It was quite a lot of training last year. So then we noticed that the rule specification was really useful. I talked about it before. So assigning the LLM to a persona, for example, an undergraduate versus a teaching assistant, influenced completely the feedback. So we settled on a lecturer at some point, which was giving good feedback, and that was fine. But it was really amazing to see how much the persona is changing the feedback. Then I talked about temperature control. We tried several temperature level, but really mathematical output, you want it to be as deterministic as possible because you want consistency. So low randomness is better. So 0 temperature is better. And then we noticed also that not only the breakup of the prompts, so how many stages and what the stages were mattered, but the prompt phrasing matters very much. So making it very precise made the feedback better, which in a way is not surprising, right? I mean, humans are the same. If you give them very precise instruction, then the feedback is going to be better. So small wording changes like identifies without proves affected completely which feedback we were giving. So at the end of the day, we had to be very careful at how precise we were giving instruction to them within these prompts. So the key lesson was that the prompt design had really a direct impact on both the quality of the feedback and the grading outcome. So careful tuning is really, and training of the LLM is really essential here, was for us. But the good news is that once you have done it once, the second year, so this year, when we generalized our tool to other lectures, it was much, much easier. So we could just use the work we had done before. And we knew also what we were doing by then. Okay, so the evaluation is still ongoing because, as I said, we've started last year. It was just for one course. And we had several problems which occurred with just on the level of the users, which I will talk about later. But so the evaluation of our tool is still ongoing. So therefore, I mean, I would be cautious, and some results are still a bit preliminary. But I would say it was really a success because we were able to get some very precise and very good feedback to the students. So there are some downsides. So we had our system was, so first of all, maybe I should say, because I had this question before, so how does it compare to ChatGPT, right? So if a student would just give the solution to ChatGPT, how does it compare to the feedback it gets with our tool? So the thing is that it's much more accurate because we prompted for it using our criteria, and much more concise. The downside is that it's still verbose compared to human graders. So you don't want it to be too concise, which is like the criticism you get when you have human graders. Okay, you just wrote a cross, you know what? But if you compare the feedback from the LLM, it's still like, you will see, I will show you later, it's still a bit verbose for my taste. On the other hand, the coverage of mathematical errors in the solution and the frequency of errors in the feedback, that was much, much better than the human graders. So as a matter of fact, the LLM detected errors which all 3 human graders hadn't detected. And we also compared the marks between human graders and between human graders and the LLM. And so I would say, because I taught the IUM for many years and I exactly know the criteria I want to have, that the marking I gave was kind of the ideal marking I would like to have. I mean, I'm surely making mistakes and everything, but I guess because I have this experience and because I designed this course, my feedback, what I would imagine to give as a feedback in general. And so the LLM was much closer to my feedback than the human markers between them. So there's a discrepancy between human mark is actually huge, right? But if you tune an LLM, use it to use certain criteria, then it will be actually very close to the ideal feedback you imagine. So this was quite good actually. But not, I mean, it was surprising at first, but it's not entirely implausible given the time limits and the fatigue human graders will have at a certain point. Right? So on the other hand, one downside we have with the LLM feedback, which we still haven't been able to completely fix it, is that it was never happy. So I mean, like, even if you had given it the exemplary solution, which is correct, and we could see it was correct and detailed and everything, it was still nitpicking on very small things, like, oh, you should have, like maybe written this instead of that. And things we don't want actually to give as feedback to our students because we don't want to discourage them. So this was a downside we had with our feedback. So on the whole, it looks like human graders were better at giving directionally correct feedback. So you should go in that direction. The big picture is maybe better, but the LLM feedback has a very sustained attention to details, and we would notice pretty much all the errors in the student proof. So it's a bit hard, of course, to objectively compare the influence these errors in both the LLM feedback and the human feedback will have, right? Because you would need to do a study for a long period of time. But we're working on it. So we're analyzing the feedback from our student perspective, and we're doing surveys. So we're trying to see really how helpful these LLM feedback really is. So for the moment, we had like really good comments from our students. So I believe this is really a helpful tool. But the analysis on this data is still ongoing. And finally, I want to discuss something which it was really useful for, and we had like an immediate success. It was proofreading of solutions. So we had a full set of problems with exemplary solutions, which were written by lecturers. And we used our system to give feedback on these exemplary solutions we had for the course. So this was, at first, it was intended to test our system so that we could test these additional feedback on the exemplary given solution. And ideally, we would have had a great feedback because those were exemplary solution. And indeed, the system performed very well. And it found lots of, at the time I wrote this, it was some errors in the IUM. So now that we have used it on the course on analysis and linear algebra, it found actually many errors. And the criticism were well-founded. So lecturers, because we have limited time, our exemplary solutions are actually not exemplary. And I think this tool is actually a very good way, and it's not harmful to anyone, right? It can only have a positive outcome because you're testing your own solutions, and you can see, in most of the cases, it was correct, and we made the correction to the exemplary solutions. So it's actually a very useful, low-cost case for such a tool. We also tried to be able to test it more because, of course, we only had 65 questions with 65 solutions. So we were thinking, if we can get the LLM to generate student-style solution for an appropriate mark, and then feed it. So we were using 2 LLMs, I need to say. So like the idea was use the first one to generate student-style solution for an appropriate mark. So top solution, which were mark 5, really bad solution, mark 0, and then something in the middle. And then we would create a larger data set, and we could use this data set to test our feedback tool more. The problem is it didn't go well at all. So it was super hard to prove, to create low-grade answers. Maybe because the LLM are too clever and they don't want to produce a bad answer. So the model was avoiding writing incorrect math proofs. Borderline answers, like which were kind of correct but not completely, were super inconsistent. So some were okay, you could have taken it as a great mark 2, mark 3 answer, but some were just either nonsense or too good to be at such a grade. High grade answer was the easiest, because I think probably the LLM is just trained to write correct answers, so it doesn't want to write bad answer. And the downside of that is also that it was usually, when it was a high-grade solution, it was way too good and too polished to be a realistic student solution. So we completely failed at that, at producing a larger data set to test our LLM. So this was not working. So the other thing that attempt to guide generation with struggling students, so we also try to give the LLM a persona doing that, like struggling student or weak student, or this time didn't help at all. So giving it, so I think it's really in the nature of the LLM that it doesn't want to produce something crappy. Simply, it doesn't want, it wants to give you a good answer, and so it's really hard to do. But I mean, I would, if anyone has an idea how to do this better, to create this data set, because that would help enormously if you want to train your LLM with the bigger the data set is, the better the training, right? So the conclusion was that LLMs are not good at simulating realistic mathematical mistakes. So how can we improve these LLM feedback? So as I said, the effective strategies were the modular pipeline, question, solution, feedback, including the question and the context with the student answer. These produced more accurate and focused feedback, so that was better. The persona improved the tone and clarity. The remaining issues were that the feedback is often too verbose. The LLMs rarely assign full marks, so it was really bad in detecting perfect solutions, and so it was really overly critical. So even for our supposedly exemplary solution, we never got a 5 out of 5. So it was very rare. And this is something we want to avoid, because you don't want to discourage students. So this is something we're working on. The conciseness has gotten much better this year. The fact that the LLM is never happy, this is still kind of a problem. But we solved that in not giving the student a mark anymore. So we don't tell them if it's incorrect or correct. We just give them the feedback. And from the feedback, we tell them, okay, if it's just nitpicking, you'll see it. And they're quite happy with that, but that's something we want to solve. So the last thing I want to talk about is how we implemented our feedback tool for the cohort of our students. So as I said, when you use such a tool with students, you have a lot of problems which can occur, and safety is one of them. So the ideal thing we would have liked to have is just a free feedback tool. If they could give any questions they wanted, any solutions they wanted, and then give feedback on that based on our prompt. But this was not possible because this was given just too much freedom, and it was too much of a risk. And also, it's kind of hard to come with an external platform. We had already a feedback platform, so which was called Lambda Feedback. So it's kind of an automated platform which gives the student feedback, but it was not using AI at all. So it was like more of formative assessment based on multiple choice questions, which were already in the system. So it didn't have this AI component at all. We were the first one to want to implement that. So yeah, it was designed for fixed format question. It was also not designed because it was not used by mathematics at the time. So it was not designed for handwritten proofs. So that was another thing we had to adapt. So the adaptation we made is that we had less freedom, and we work on these fixed question sets I talked about already. We computed the solutions to all of them so that it could be integrated in this platform. But unfortunately, the platform had constraints. So we have no follow-up dialogue or interactivity, which is kind of one of the advantages of the LLM, is to be able to have a dialogue with the thing. So to be able to give the solution, the LLM gives the feedback, and then you correct the feedback and say, oh, how is it now? And then the LLM corrects it. But we didn't have this possibility this year. They're working on it, so we might have it very soon, actually. So what we have is that we just give each of the students 6 attempts for each of the questions. It was also a problem of cost. And so they could just give their solution, get feedback, and then try again 6 times for each question. The second problem we had last year is that the handwriting recognition mechanism they used on the platform was different from the one we wanted to use. So we had to, and especially didn't recognize math symbols that well. So we had to deactivate the handwriting input. And so the students had to type all of their solution. And this was a criticism. So they were very happy with the system, but they were quite unhappy with the interface and how, like at the user level. So maybe I can tell you the lesson we learned to wrap up, and then tell you what we plan for the future and what we have done this year. So what worked, I think I talked in details about this, like breaking the task into steps, use careful personas. And what worked is that we really, really had good feedback from our students. And we felt that especially for the weaker students, these help. So because they have a final at the end of this course, and usually it used to be like quite a lot of students were at the bottom tail, and we had the feeling that this really helped to make the tail higher. So there were more students who passed the course, and a lot of them told us that actually this feedback really helped them with mathematical writing. So what didn't really work is that our prompt optimization was limited to the size of a data set. We couldn't get a bigger data set to work on. This was partly solved this year because we had additional lecturers. Lecturers who agreed to work with our tools. So we have quite a large pool of questions we can train our system on. I said before, the LLM was still verbose. We got it to make it better, but it's still not at the level I would like, and it was never happy. So it tended to be unhappy even with correct solution. And from the deployment, like what didn't work that well is like if you have a fixed platform you want to integrate your LLM tool on, especially for mathematical writing, it needs to have certain features. So you need to be careful about certain features. So for example, I think it's very important that students can use tablets and that the system is able to recognize handwriting and especially mathematical formulas. So this year we have that. And it makes a huge difference. Like lots more students are using it. They are much more happy with it. And also they are able to scan the answer and to upload it to the system, which works pretty good as well. And that also makes a huge difference. So they have they can type, they can write, and they can scan pictures. And so for the users, it's simply much better. So in order to implement this tool, you really also need to take care about this user side of the thing. And the second thing, which was a bit difficult in our case, is to upload our questions and the way we wanted to have it, like to have the interface we wanted to have on this platform. And I think this would be probably a problem with any platform you use, that you need quite a lot of work in order for the students to be able to use your tool properly the way you want. So, I mean, like from what I've said, the future work is, yeah, it's quite clear. We need to improve the prompt design to reduce this unhappiness thing of the LLM and to make it better reward correct work. We want to expand our data set to be able to train it better. So we've partly done that, but I think it would be better to, it would be nice to be able to create these data sets as well. To expand platform capabilities. So there was also a problem where the students were typing the LaTeX because it was not rendering properly. Ideally, we would like to have interactive feedback. So I think it's rather than to have to re-enter the solution every time, it would be nice to have, like the feature ChatGPT has, to be able to have a dialogue with the LLM. Yeah, so I mean, like extend the platform capability. So I've said that already. And then, I mean, like the next call, we've done that to some extent, because now all the first year lectures, except in stats, are using statistics, are using our tool. And for the moment, I think like we have very, very good feedback on it. It's kind of helpful. So of course we will see. So we still need to survey the student to analyze data. We want also to go through the feedback the LLM gave towards the year. That would give us also more data to be able to train it. And I mean, like other things are coming to mind as well. I think we have lots of Chinese students. Is it possible to have this tool in multiple languages to help them? Can you adapt the tool to student progress? And I think it's perfectly doable, basically because of these curated prompts we use. So you can just replace one prompt by another, changing the criteria. So I think this is this is what we plan to do in the future. And so I thank you for listening to me. Maybe before the question, I should show you the tool in the platform we use at Imperial College, and then I would be happy to answer questions. So I stop sharing, and I will try to reshare. Can you see that?
Yes.
Yeah, I have to find it now on my. I just have to find where I put it. Where is it? Here it is. Okay. So this is an example of the interface we have. Can you see the interface with the analysis module?
Yes, yes.
Okay. And so this is what the student would see here. So they have problem sheet 1. So this is just a problem sheet 1. And these are the different questions on the problem sheet 1. So for the moment, we just looked at supremum, infimum, and started with sequences. So these will be a typical exercise from an analysis 1 problem sheet. And this is the response area. So here, they can just type using LaTeX, kind of pseudo-LaTeX. Or they could decide to draw. So they had to click on draw, and this is compatible with tablets. And this is for scanning. So they can just write down their work, scan their work, and then it will be processed by the system. So here, I just chose to write down a solution, which is not perfect, right? I didn't write it well, so to be able to get some useful criticism. So the question is, show that the set has no largest element, so no maximum. And I write a very rough proof, right, like some of our students would do. And then I ask to check I ask the feedback to give the tool to give me feedback. So bear with me. I hope it works. Cross fingers it worked. It can take some time. So this is another thing we want to make better, that it can take quite a bit of time. Okay, and here's the feedback. Right, so and it follows exactly our criteria. So what we want in a first year course is proper use of definition of axiom. So it will check for that. And it finds that I'm not using explicitly the definition of the largest element. It is true, right? Then my choice of a counterexample, the number is not always greater than L unless you justify that L greater than 1. So this is a bit picky, but it's correct, right? And I don't have enough detail and justification in my proof. So I think it's rather good feedback. As I told you before, it's a bit verbose. So I think it would be a bit better. You don't really need to have this level of, of details. But I think it's, I mean, like the mathematician will judge. I think it's not too bad of a feedback, really. So, and I mean, we've tested it, and it's really, really rare that we can detect errors in the feedback of the LLM. So basically, it almost never happens when, at least when we have trained it enough time. Okay, I think I stop here. And yeah, thank you so much for listening. I hope it was useful.